This is section 7.4, overlapping triangles. Okay, so what overlapping triangles are they're basically kind of a picture where you are sharing points or sides or something like that. So basically we've got two triangles here that are overlapping with each other. I've got one in yellow, DAB, and then I've got one in green, CAB. Okay, so you can tell there that both in the yellow triangle and the green triangle, they're both having sharing that common side AB. Okay, so that'll be helpful in proofs because if they're both sharing that side, whatever the distance from A to B is the same from B to A, so basically those sides would have to be the same length. A lot of times what I'll do with these proofs, because it can get kind of confusing having both of your triangles together like that, what I'll do is I'll pull the two triangles out separately so I can look at them as two different parts versus all kind of clustered together, because when we start filling in like angle measures and sides that match up, sometimes it gets kind of confusing, so a lot of times I'll pull them apart to two separate triangles. So like I've got the yellow one there, DAB, and then also the green one there, CAB, so I just split them apart. Okay, so we're going to go to the example sheet here. So the first one we're looking at is this one here. So we've got this picture, and we are given that NMK, that angle, and NLJ, that angle, are congruent. And then also from M to K and L to J, those are also congruent. And we are supposed to prove that N to K is congruent to N to J. Alright, so I set this one up on the back here. So basically what we are starting with is that angle NMK is congruent to angle NLJ, which they told us, and then same with those side lengths that they told us. So that first one's just a given one. Okay, so now this is where I kind of usually do my split here. So I drew it up there, but I'm going to redraw it down here. So the two triangles that I'm looking at here, because the ones they want me to show are congruent, are NMK and NLJ. So one of my triangles, NMK, is that one right there. And then my other triangle I'm looking at is NLJ. So that one right there. So what I like to do, since it's kind of a whole lot going on with that picture right there, what I like to do is I like to pull these apart. So we'll see how well I can draw this here. Okay, so now imagine this is those two triangles split apart, where I've got the green one here, like that, and I've got the yellow one here, like that. Okay, and I'll throw in my letters. So both of them, their top point was N there. And then also I had for the yellow one, I've got M here, and then it goes down to K. And then for my green one, I've got N, L for that one, and then J for my corner one there. Okay, so the things that I know match up, I know that I've got angle M and angle L matching up to be the same. And I've got M to K, so this side matching up with L to J, that side. So currently I've got two sides that match up there and two angles that match up. And what I know is with my congruence theorems, basically I have to have three different things matching up. So I basically need an extra side or an extra angle to kind of show that this is matching up here. So what's kind of convenient about the overlapping triangles is they're sharing parts. So if I look here at both the green one and the yellow one, those are both sharing that angle N. So say on the yellow one, angle N was like 40 degrees. Well, the green one is exactly that same exact angle N there. So that one over here for N would also have to be 40 degrees. So I know here whatever this N is, the N here is exactly the same because they're overlapping there. They're sharing that same exact angle N. So now, for my proof, when it says, okay, now I want to show that the green triangle and the yellow triangle are congruent to each other, I go to my three letters things, and I'm going angle, angle, side. Same thing here, angle, angle, side. So for my congruence theorem, I go AAS, congruence theorem. And then now that we know both of those two triangles are congruent, now what we're saying is the side N to K, so N to K would be here, and N to J would be there. Now they want us to say that those two sides are congruent. So if we're going from the whole thing congruent to part of it, or one of the sides being congruent, that's CPCF. So CPCF theorem, corresponding parts of congruent figures. Okay, so that's the first one. Second one here, we're back to the front page. So we've got segment AF is parallel with segment BE, and then we also have that AF, that side, is congruent to BE, and then angle F and angle E are congruent to each other. And we are supposed to prove that the segment from F to C is congruent to the segment from E to D. Okay, so going through our stuff here, first one we've got is just given, right? Because it says that those two sides are parallel to each other. And now the next one that we're looking at here is angle FAC, so FAC, that one, and angle EBD, that one. Okay, so what I would think here is I would go, okay, well, if I know that these lines are parallel to each other, and I kind of extend them out there, I'd go, okay, well, I got two parallel lines. This line here would be my transversal. Those two angles there are both in the upper right corner of those parallel lines, so this would be same position, so it would be corresponding angles. So corresponding angles postulate. Okay, so now I've got those angles matching up, and then they give me a couple more of the givens there, so segment AF and segment BE, those two match up, and then angle F and angle E match up. So now they want me to come up with my three-letter deal here, where I go, okay, my two triangles here, one of them is AFC, that one right there is congruent to my other one, BED, that one right there. And you can draw them separate if you want to. So if I'm looking for my three-letter deal here, I'd go, okay, well, I've got this angle here, I've got this side, and I've got an angle. Same sitch here, angle, side, angle. So I would go ASA, congruence theorem for that one. And then your steps, again, I don't really care about the steps for the test, but if it does come up on your assignment, basically you're getting that from step 2 because that was one of the angles that we needed. And then we had the side that matched up for step 3, so that side and that side. And then step 4 matched up F and E, so that's how we got angle, side, angle on that. Okay, and then again, we're going from those two triangles being congruent to now one of their parts matches up to be congruent, or a segment. So again, this one's CPCF theorem. Okay, and then we've got one more proof here. So this one I did on the back, so we'll read it here. So we've got segment AB there is congruent to segment CD, and then segment AD, so there to there, is congruent to C to B, and then angle B and angle D are congruent. And we're supposed to prove that angle BAD and angle DCB are congruent to each other. Alright, so with this one, we are starting off with those segments matching up and then those angles matching up. Well, that's exactly what they told us in the given. So that first one is given. Okay, now we are jumping to right away, now that we've got that information, we're jumping to our two triangles be congruent, so this is where we're looking for our three-letter congruence theorem. So 3 letters, congruence theorem. Okay, so looking at my shapes here, I've got one like that that's ABC, and then my other one is CDA, that one right there. So if you want to, it might be helpful to redraw this one. So I've got one triangle there, the yellow one, and then I should have given myself some more room here. This would be the green one. So my yellow one, was A, B, C, and then my green one, this other one here, is that A, D, C. Okay, so the things that I had there, I had AB matching up with CD, I had AD matching up with CB, and then I had angle B matching up with angle D, and those were the pieces of information from my given. Okay, so now if I'm looking at my 3-letter thing, I feel like it's a lot easier to kind of see here. I could go side, angle, side, and also side, angle, side. So this would be side, angle, side congruence theorem. And now, for the next one, we're going from the whole thing being congruent to now parts match up to be congruent. So the parts that they're jumping to are DAC, so DAC, that one right there, and BCA, that one right there would be corresponding, and then BAC, that one, and DCA, that one would also match up. So if we are going from the whole shape being congruent to just a part of it being congruent or an angle, that would be CPCF theorem again. And then now, the only thing that's really changing here is they're switching from having congruent signs to now having equal signs. So all the letters are staying exactly the same, but they're switching from congruent signs to equal signs. So if you remember back a couple chapters ago, this is called angle congruence theorem. Okay, so we had an angle congruence theorem where all we switched was the congruent to the equals, and we also had segment congruence theorem where we basically had the same thing, congruent segments and then equal segments. Okay. So now that we know that they're equal, now we're saying some other stuff here. So now we are saying angle BAD. So we're actually going to have to go back to our original picture here because we're looking at angle BAD. So that one right there. So this is a little bit tricky here, but what's happening is they're taking away part of these angles. So they're going BAD, and then the other one they've got is DCB. So that one there, they're saying match up. I'm going to shade those in so they're a little different. So with this one, basically what we're doing is we're subtracting or kind of taking away part of the angle. So what we're starting with here is angle BAC, that full angle there, which would be this here. And we're taking away this corner here, which was DAC. So that one there. So since we're subtracting the same angle measure from each of these things, because the same thing's happening over here where you're subtracting away this, here I'll use a different color here. We're subtracting away this inside part here from both of those bigger angles. This is addition property of equality, and I know it's been a long time since we've done that one. So this one's kind of a hard one to come up with, but this is addition property of equality, because basically they're adding these two angles together to get that bigger angle. Same thing over here, they're adding this angle here, the black one, with the red one to get that bigger angle, except for we're working at opposite, which we would actually be like subtracting away the red from each of those to get what's left for the black. But we know we don't have a subtraction property, we only have an addition one. That's why we have to go addition property of equality on that. That one's kind of a tricky one to get to. But this last one here is not bad because all they're doing is they are switching our equal signs to our congruent signs, but the letters are staying exactly the same. So if that's all we're switching, that's really similar to what we had up here where we switched from congruent to equal. So that's that same angle congruence theorem. So part of that's kind of tricky there. Alright, so that is it for our notes. So your assignment is on page 403, 1 to 10 all. There is a sheet that kind of goes with the assignment that it wouldn't be a bad idea to print off if you can, or you can kind of look at it because that sets up a lot of your proofs for you so you don't have to come up with those out of thin air.